So digitals, we have number systems. First, we need to know the conversion of number system, what type of number systems are there. All these things we will learn here. Okay? Number systems. Okay. So in that, first binary number system. What is the binary number system? We'll learn here. Binary number system. So binary, after that octal number system, and then decimal number systems, and last one is hexadecimal. So number system. So what is the base of this binary number system? Base or radix, we can call it as a base or radix. Here the base of the binary number system is 2, and then octal is 8, decimal is 10, and hexadecimal is 16. Okay, these are the bases or radix. And then ranges, what are the ranges we have? So in the range we have binary number system 0 to 1. That means we have 1 only. And then octal number system, the range is 0 to 7. That means we have a number system like 0 to 0 comma 1 comma 2 comma 3 comma and so on, so up to 7 numbers we have. Okay, so this is octal number system. And then decimal 0 to 9. Okay, so in this, uh, what are the numbers are having 0 comma 1 comma 2 and so on, so up to 9 values we are having. Do not cross this 9, that is the decimal number system. Here octal, it is not crossing that 7. And then hexadecimal, so 0 to 15. Okay, so 0 to 15 is there, that is. And then after 9, 0 to 9 is the numbers, and then 10 is represented with A, and then 11 is represented with B, and 12 is represented with C, and 13 is represented with D, and then 14 is represented with E, 15 is represented with F. So these are the ranges. And then examples, how the binary number systems are represented. Some examples here. Okay, what are the examples? So binary number system in Verilog, how we can represent means, suppose 2-bit binary, so size is 2, and then your number is binary number system 2 tick B 0 1. In that way we will represent. Or 3 tick binary want to represent that, so 3 bit binary 3 tick B 1 0 1. In this way we will represent. Or sometimes 5 tick or 8 tick 8-bit binary number system we will represent. So that means 8 tick B 1 0 1 0 1 0 1 0. So in this way we will represent that binary number system. Okay. Are you understood, all of you? Ramya and Priya? Okay, okay. So octal number system. So in very how we can represent means. So octal means see, this is the 8 bits, right? Right. So eight numbers we have. So the 8, that means binary numbers for represent 2 power 3, right? So 3 bits we can represent number, 3 bit we can represent. So then 9 tick octal we can represent that. So 9 bit number. So 9 octal, and the number do not cross this 7. 7 is not crossing. That means 2, 3, 4. In this way we can represent, because 2 is having 3-bit binary number and 3-bit number binary number, and 4 we can also represent 3-bit binary number. And also we present 15 tick octal, so 15 bit octal number. So in this 15 tick octal, how can we represent 7 5, 3, 1, 2. In this way, we can represent. These are the examples of binary numbers and octal numbers representation. And then decimal numbers representation, that is the base 10 is represented. Here, decimal number, 4 numbers we have. So that means 2 power, it's because 2 power 3 is 8, and then we have 2 power 4. Okay, 2 power 4, then 10 value is also coming. So that means 4 bit binaries are we are using. Then 16 tick decimal, so 4 numbers we can represent. So 4 numbers do not cross the number 9. Okay, range is 0 to 9, and we do not number 9. Okay, so 1, 3, 5, 7, so 16 tick decimal number we are representing. And also hexadecimal representation. Similarly, we can also represent 32 tick 32 bit number. In that 32 bit number, 32 tick decimal. So here, 1, 2, 3, 4, 5, 6, 7, 8. In this way, we will represent the 32 bit 32 tick hexadecimal, sorry, decimal number representation. And similarly, hexadecimal number representation. Hexadecimal, we can represent 16 tick hexadecimal. So 16 bit binary, 16 tick 16 bit hexadecimal number we are representing. So all A's I am representing. So 4 A's I am representing, each A 4 bits it will take. So then 6 can represent here 16 bit number. And similarly 32 bit number we can represent 32 tick hexadecimal, D, E, A, D. So here 8 bits, 16 bits, and also we have another 8 bits. Okay, that B is represented. Okay, 32 tick number we have represented. In that way, we need number systems here. Similarly, we need to convert one number system to another number system. Number systems conversions are needed. Okay, so one number system is converted to another number system, like any number system. So one number to another number, how to convert that? Okay, so that means we can check that any number system, any base. Okay, here I'm taking. That means some x is the base number, and any base to decimal I'm converting. That means any base. So any base means either or hexadecimal or octal. So all should be converted into some numbers I'm taking. A, B, C, D numbers I'm taking. That should be converted to decimal number system. How we can convert this decimal number system means, so whatever the base we have, okay, so A into x power 3. Okay, that means here position is there. This is the position, 0th position, first position, and second position, third position. Similarly, place value is A. So place value into base to the power of position. In that way, we can take. And similarly, B into x power 2 plus into x power 1. Okay, so D into x power 0. In this way, get the decimal numbers. Okay, so this is the decimal number system we will get. So here x, y, z, and w. So in this way, we will get that number system. That is the conversion of any base to decimal. Okay, so need when we need in our uh, real time industry means, so some protocols are there. In that protocols they will give you start at decimal number, so 1 0 a 1 c 1 f 2. In this way they will give you, or some 0 x, okay, 1 f f c. In this way they will start address. So then need to convert the start address to decimal number. So that conversion we need. At this situation, we need conversion convert this hexadecimal number to decimal number system. Okay, so how we can convert? So just you can take any number system, hexadecimal number system. I'm taking say one FC. I'm taking. Okay, this is hexadecimal system. Okay, hexadecimal converted to decimal. Okay, so decimal I want to convert here. How I can convert? So place values are 0th place, first place, and place, third place. So in this way we have place values. So 1 into base is 16 and place value is 3. Okay, 1 into 16 power 3 and then F means okay, so 15 into and then 16 power 2 plus F is again okay 15 into 16 power 1 plus C means A means 10, B means 11, C means 12. So 12 is 16 power 0. In this way, we need to convert hexadecimal to decimal number system. What is the 16 power 3 value? 16 power 3 means so 4 KB boundary, that is uh, 4096. Yeah. And 15 into 256, some 3840. Uh, so then again 15 into 16 means that 240, right? So 15, 16, 16 is 256. So 16, 15 is 240. So 240 plus 12. Okay. So in this way we need to convert our hexadecimal number to decimal number system. You can add all these values. You will get that decimal value. Okay. So this one type of conversion, that is hexadecimal to decimal. Okay, hexadecimal to decimal conversion we have. Similarly, we need to convert that any that means decimal to any base. Decimal to any base means so reverse of operation, that we need to divide. Okay, this just you can take decimal that should be converted to any base, either binary or octal or hexadecimal. Okay, these three conversions you can take that. So what is the number I'm taking here? X, Y, Z, W, that is the decimal number I'm converting. Okay, that should be converted to either 2 or base 8 or base 16. Okay, just you need to divide the given number. Okay, X, Y, Z, W, whatever the number you have taken, that should be converted to binary. You need to divide that number with 2. And then if you want to convert that number into octal, then just divide with 8. X, Y, Z, W. So that should be divided 8. And similarly, you need to convert into hexadecimal. You need to divide that X, Y, Z, W with 16. So in this way, we will get decimal to octal, decimal to binary, decimal to hexadecimal. These conversions will be happening. Clear? Any doubt in this? How to converting to hexadecimal to decimal, and then octal to decimal, and then binary to decimal. So there is no problem in that conversion, right? Similarly, you can convert decimal to octal, decimal to binary, and then decimal to hexadecimal. So any number system you need to convert here. Okay, so just I want to take one example like uh, some B that is not a 872. 872, that is the decimal number into binary. So just you need to divide this 872 with 2 only. Okay, so you can convert that. 872 that should be divisible by with 2. Divisible with 2 means 4 times and 3 times. Remainder is 1 and then 12 6 times remainder is 0. Similarly, so 2 division 436 is divisible. So 218 remainder is 0. Similarly, so 218 is divided with 10 times, so 20, 89 times, so remainder is still 0. And again, uh, 109 is divided with 2, so 50 times remainder is 1. Okay, so and then 27 times remainder is still 0. Okay, so 13 times remainder is the value, remainder is 1. And then 2 6 times, so remainder is 1. And then 2 6, okay, so 2 6 remainder is 1. And then you will divide with 3 times, remainder is 0. And again, so 2 times 1 time, remainder is 1. So now we need to write the number from downwards to upward. Okay, so in this way we can write. So then what is the value here? This number it was already I have written there. Okay, 101, 101, and again 101. Okay, this is my binary number. How we know this number is correct or not? You can check that. Okay, this is 2 power 0 and this is 2 power 1 and then 2 power 2. Okay, 2 power 3, 2. Okay, so 2 power 5, 2 power 6, 2 power 7 and 2 power 8. So 2 power 8 means what is the value? This value 256, right? Sorry, 2 power 8 means 2 power 7 is 128. Okay, 2 power 8 means 256, right? No, I think so. 101, 101, triple zero. Okay, 9 bits. So 0, 3, the 2 power 8. 2 power 8 means 256. 256 plus 60, 2 power. Yeah, yeah. Something we lost somewhere. Just give me a minute. Okay, something that value. Okay, just 872 we can take here. So 2, that is 6, that is correct, right? 4 remainder is 0. Okay, then so again 2 times 1 time and then 218, again remainder is 0. Again, so 218, 2 means 109, 101, again remainder is 0. Okay, so then 50 is that again remainder is 1. Then 54 is divided with 2, 27, 27 remainder is 0. Up to this, okay. Uh, this is 13 times, so remainder is okay. So then 2 is divided with 6 times, remainder is 1. Okay, and then 3 times, so remainder is 0. Okay, so again 1 time remainder is 1. Okay, so now What is the value we got? 1 1 0. Okay, again 1 1 1 0. Okay, 1 triple 0. Okay, so we go. So here we missed that because here we can write in the next page, right? That's why we missed that. So this is the binary. Then this is the 2 power 0 and 2 power 1, 2 power 2, 2 power 3. So 2 power 4. Okay. So 2 power 5, 2 power 6, and then 2 power 7, 2 power 8, and 2 power 9. So 2 power 8 means 5, right? So this is 512. This is 256. 256 plus 5, 720, 768, right? 768. This 768 plus 64. 768 plus 64, 772 and 82. Okay, 832 plus 832. Then 864. 864 plus 8. Then 872. Got the number, right? That is the hexadecimal to hexadecimal number conversion. Sorry, decimal to binary conversion. This is the decimal to binary. Similarly, here my binary number. Okay, so what is the binary number? Is 110 triple double 10 and triple 0. This is the binary number. I want to convert this binary number to octal. Okay. So how I can convert that octal number means simply I can combine that three bits here. So 3 is one number. Okay. And then these 3 bits one number. So this is 5 and this is 0, and these 3 bits will be converted again 5, and here two zeros I will add here. Okay, so then 1, then is the value I got 1550. That is the octal number. So here I'm converting binary to octal. Binary to octal conversion. Clear? So simple conversion. How we can convert binary to octal means, so first we need to convert this number to decimal. First we need to convert number to decimal, binary decimal. After that we need to divide this decimal number with octal, right? So what is the decimal number we got here? 872. Okay, 872 is the decimal number that should be converted with octal. So we divide with 8. Okay, one time, and 72 means, so how many times it is converting? 109 times. So 109 times, remainder is 0. Okay, so again 8. So one time, remainder 29. So 29, 3 is 24, remainder is 5. So again 8, one time, remainder is 5. So in this way we can write. So simply whatever the number we have, that number I am not converted into decimal number, and directly I have converted to octal number. How I am converting? 3 bits I am segmented, right? Whatever the binary number I got, that number I am segmented to 3 numbers. That decimal to binary to octal conversion. Okay, we got that 1550. So this is the octal number. Similarly, but this binary to hexadecimal. Okay, binary to hexadecimal. How can you convert that? Binary to hexadecimal. What is the binary number we got? 110 110 110 110 1000. So this is my binary number that should be converted into hexadecimal number. How I can convert here means here also we can convert with the shortcut way. So just I am segmenting these binary number into 4 bits. Okay. So then I will convert. I will get that hexadecimal number. So 0 means 8. Okay. 0 double O means 6. Okay, 0 double 0 double 1 means 3. So this number is 3, this number is 6, this number is 8. So then I got the hexadecimal is 368. So this is the shortcut way. Similarly, here I convert this binary number to decimal number. Okay, after that I will divide with decimal number with 16. Then I will get that. What is I got that decimal number 872, right? 872. 872 is my decimal number that should be divisible by 16. So 8, 5 times 4 times 64, 5 times 80. Okay, remainder is 72. 72 means 4 times 64. So 4 times 64 and then remainder is 8. 8 is the remainder. Similarly, 16 we can divide with 3 times 16 is 48. So 3 times and remainder is 6. Then we will get 368 is the hexadecimal number. Are you getting my point, all of you? Okay. So this is the number systems conversion. One number system is converted to another number system. So now I just want to know, do you know how to represent the binary numbers? So binary numbers, 2-bit binary number, can you represent that? So 2 binary, we have 2 bits, 2 power 0 and then 2 power 1. That means 1 and 2. So 2-bit means 4 combinations we will get. So 2, 1, 2. So 0, 0, 0, 1 and 1, 0, 1, 1. How I am written here? So this is the 0 binary and then okay, this is for 2 and this is for 3. So just what are the number I want to get? So both 1 and 2 will be absent. 0 means logic 0 means absent. That particular number is absent. So that particular number is absent. So logic 0 is absent. Logic 1 means logic that number is present here. Okay. So 1 means 0, 0 means it is 2 is absent, 1 is present. Means at 2 place we are giving the value 1 and 1 place no need, that why so 0 is placed and 3 means both are 1 1. So in this way we are connecting. Clear? So that is the 2-bit binary number system we are representing. Similarly, 3-bit binary, how can you represent the 3-bit binary? So 3-bit means 8 combinations we will get, right? So 8-bit binary. So 3-bit binary, how can you represent? 2 power 2, 2 power 1 and 2 power 0. Okay, so 1, 2, 4. Okay, in this way we will represent. So 0 binary number, how can you represent? All are zeros. 4, 2, 1 and then 1 means only 1 and 2 and 4 should be 0 and then 2 means 4 is 0, 2 is 1 and 1 is 0 and 3 means so 4 is 0, 2 is 1 and is 1. 4 means 4 place is 1 and then 2 is 0 and 1 is 0. 5 means 4 is 1 and 1 is 1. 6 means 4 is 1, 2 is 1 and then 1 is 0. 7 means all are ones, 4, 2, 1. So all getting 1 here. Okay, this is 3-bit binary number system. Similarly, 4-bit binary number system we will write here. So 4-bit binary one code we can follow. 4-bit binary number system. So 4-bit binary number system, how can you represent? 2 power 3, 2 power 2, and 2 power 1, 2 power 0. Okay, so 0 means all are zeros. Okay, 0, 0, 0, 0. 1 means so 0, 0, 0, 1. Okay, 2 power 0 value is only present because 2 power 0 means 1, right? Okay, 2 power 0 value. Here 2 power 0 value is 1 and 2 power 1 is 2, 2 power 2, okay, 2 power 3 means 8. That is the binary number system, 8421 code calling that. And 2 means, so what is the value? At 2 place we are 1, we are placing 1 and 8, 4 and 1 is also 0. 3 means, so 2 plus 1, okay, so then 4 and 8 should be 0. And 4 means so 1 and remaining all are zeros here. And 5 means so 0, 1, 1, 0. Sorry, 0, 1, 0, 1. Okay, so 5 is that 0, 1, 0, 1. 6 means 0, double 1, 0. And 7 means, okay, so 0, triple 1. And 8 means 1, triple 0. 9 means 1, double 0, 1. And 10 means 1, 0. Are you getting my point right? All of you. 11 means 1, 0, double 1. 12 means 8 plus 4, 12. Then 2 and 1 should be 0. 13 means 8 plus 4 plus 1. Then 13. 14 means 8 plus 4 plus 2. 15 means all ones. 8 plus 4 plus 2 plus 1. This is the binary number system, 4-bit binary number. In this way, you can write any number. Any number, see, up to this, we can write 0 to 9. We can write as a BCD, binary coded decimal, called as BCD, binary coded decimal. That means 0 to 9 only we can take. And binary number system means 0 to 15. In this hexadecimal, 10 is represented with A, and 11 is represented with B, and 12 is represented with C, and 14 is represented with D. Sorry, 10 is represented with A, and then 11 is represented with B, and then 13 is represented with D, 14 is represented with E, and 15 is represented. Okay, so this is the hexadecimal number system convert. So hexadecimal numbers representation. Okay, so after 10 the numbers are represented with letters. Are you understood how we are converting binary to hexadecimal, binary to decimal, binary to octal, and then any base to decimal to any base? So that means any base to any decimal number is giving, that should be converted to binary, that should be converted to hexadecimal, and then same converted should be octal. Okay, so this is the number system conversion. So next we need to know that binary to gray code conversion, how to convert that binary to gray code. Okay, so binary to gray code conversion, how we can convert here is, so just take the binary numbers, any binary numbers you can take. So suppose B3 is the most significant bit and B2 is my most significant bit one, B1 and B0. Okay, similarly, I will get that. So gray code number. So gray code number is G3 and 2, G1 and so in this way we can convert that binary to gray code content. So first this is the number B3. So B3 should be same as G3. Whatever the B3 number is there, that should be converted to same. And then uh, this is the G3 number. Okay, so G3 is same. And then B3 should be converted to do the decimal with XS3, do the XS3 code with B2, then we will get G2 value here. And B2 and B1 do the XS3, so then we will get G1. B1 and B0 do the XS3 code, so exclusive OR operation we can done, and then we will get G0. Just what is the B3 is there, that as is we can write in G3, so that is the gray code number, and do the excess. So this exclusive OR operation we are doing in between the B3 and 2. So B3 and B2 do the exclusive OR operation, XOR operation we are doing here, and then we will get put like G2. Again, B2, B1 do the XOR operation, and we will get G1 here. Then B1, B0 do the XOR operation, and we will get that G0 here. So in this way we can write that that gray code conversion. Gray code conversion. Suppose I'm taking all the binary numbers 0, 0, 0, okay, 0, 0, 0, 1 and 0, 0, 1, 0. Okay, so 0, 0, 1, 1, 0, 0, sorry, 0, 1, 0, 0, 0, 0, 1, okay, 1, 1, triple 0, 1, 0, 0, 1, 1, 0, 1, 0, okay, 1, 0, double 1, and 1, 0, 1, 1, 0, 0, 1, 1, 0, 1, 1, 0, all ones. In this way, I have written a binary number. This is my B3, B2, B1, and B0. So then I need to convert gray code. So G3, G2, G0. So just I am taking any number like 1, 0, 1, 0. I am taking the binary number. So this binary number is that B3 and B2, B1 and then B0. I am writing that this value should be same. That is that G3. Okay. So G3 value, whatever the B3 value is there, that value I am returning as is as a G3, and do the XOR operation between the B3 and so B3 and B2 the XOR operation. Then I will get that 1 XOR with 0 means 1 we are getting. That is the G2 G value. And similarly, do the XOR operation between that B2 and B1. Okay, so B2 and B1, I will get that 0 and XOR with 1 is 1 here. Okay, so that is the value. And 1 XOR with 0, so I am getting the value is 1 here. This is G1 and this is G0. Okay, so in that way, I am getting the, so then gray code G3 equal to B3 is as is value I am getting, and then 2 is equals to what is the formula, B3 exclusive or with XOR with B2. Okay, B3 XOR with B2. and only G1 equal to what is the exclusive OR operation here? B2 B2 XOR with B1. G not equal to what is the answer we get? So B1 XOR with B naught. B naught. So in this way, we will get the gray code number. So exclusive OR operation means just any two numbers you can take. So A, B, I'm taking that. So 0, 0. Even number of ones are present means that XOR operation A XOR B value is 0. Okay. Odd number of ones present means your use or operation should be 1. 1 0, okay, your output is 1, and 1 1 your output is 0. This is the XOR operation value. Okay, so how we are doing that XOR operation here? Okay, exclusive OR operation. Similarly, you can convert this. So 0 means 0 here, and then 0 XOR with 0 means again 0, and 0 XOR with 0 means again 0, 0 XOR with 0 means again 0. Similarly, 0, 0 XOR with 0, 0, 0 XOR with 0, 0, 0 XOR with 1 is 1, and then similarly 0, 0 XOR with 0 is 0, 0 XOR with 1 is 1, 1 XOR with 0 is 1. Again 0, and 0 XOR with 0 is 0, 0 XOR with 1 is 1, 1 with 1 is 0. So 0, 1, 1, 0, and 0, 1, tell me. So 0, 1, 1. Okay. Again 0, 1, 0, 0. Okay. 1, 1, 1, 0, 0. Okay. 1, 1, 0, 1. Okay, 1. How do you convert 0 XOR with 1? 1. 0 XOR with 1. 1. 1 XOR with 0. 1. 1. So 1 XOR with 0. So 1. Okay. Okay, 0 XOR with 1. Okay, 1 XOR with 1. 0. Okay, odd number of ones is present means your output is always 1. Even number of ones is present, output is always 0. Okay, so 1, even here even number of ones are there, 0. Okay, odd number of one there, so 1, and even number of ones is 0. Okay, 0, 0. Again 1, 0, 1, 1. Okay, so 1, okay, 0, 0, 1, and 1, 0, 0, 0. This is the binary to gray code conversion. So this was important. So most of the interviews they will ask you how do you convert that binary to gray code. Similarly, gray code to binary. Gray code to binary means so here gray code we have as a gray to binary conversion. How we are converting gray code to binary? So G3 is the gray code and G2, G1, G0. Again, we are we are taking the value as is 3, but here we are doing exclusive OR operation between the output to input. Okay, B3 XOR with G2. So in this way, we do the XOR operation. This is the operation between B3 to G2. Then I am getting that B2 here. Again, B2 to Z1, I am doing the exclusive OR operation. Then I am getting the binary value is B1. Okay, so again, do the exclusive OR operation between the B1 and G0. I am getting B0 value. So here B3 means what is the output you are getting? G3. Okay. So B2 means that XOR with B3 XOR with then B2 I'm getting. B1 that is with B2 XOR with G1, and then B0 is that B XOR with G0. In this way, we will get the gray code to binary operation. Okay, just take any binary gray code number. So just previously I'm taking that all ones. Okay, so this is all ones. I'm taking as a gray. It is my gray code number G3, G2, G1, G0. Similarly, I'm converting this gray code to binary. So how I'm converting this G3 value as we are getting at the output side of. Okay, so then B3 with output is doing the XOR operation with input, then XOR with 1 is 0, 0 XOR with 1 is 0 is expression with 1, then I'm getting the output is 1 again. So 1 is doing the XOR operation with 1, I'm getting the output is 0 here. So this is the gray code to binary conversion. Now I am getting that B2 value and B1 value and B0 value. Similarly, you can take any gray code is G3, G2, G1 and G0. So take binary number. So the gray code number 000. Okay, so 0001. Okay, so 0010 0011 and 1 sorry 0100. Okay, 0101 double 10. Okay, 0 111 and 1000 and 1 1 1 0 1 1 1 0 sorry 1 1 0 0 again 1 1 0 1 1 triple 1 0 then so these are my gray code numbers. Any gray code numbers I am taking that. So now I am converting into binary number B3, B2, B1 and B0. Okay, what is the value we are getting? I am getting the values like this way. So B3 value as it is we can write in the G3 value as it is we can write at the B3 side. So G3, B3 both are same. Okay, then B3 XOR with then I am getting 0 XOR with 0 0. Again 0 XOR with 0 0 and 0 XOR 0 I am getting 0 here. Again 0 we should so 0 XOR with 0 again 0. 0 XOR with 0 again 0. So 0 XOR with 1 1. Okay, so 0 uh, and 1. Okay, so because 0 XOR with 1 is 1 and 1 XOR with 0 is 1 and 0 XOR with 0 is 0. Okay, and again 0 XOR with 1 XOR with 1 0 and 0 XOR with 1 is 1 1 XOR with 0 is 1 1 XOR with 0 is 1. Similarly, 0 XOR with 1. Okay, this 1 XOR with 0 is 1 and XOR with 1 is 0. Okay, so 0 XOR with 1 is 1 XOR with is 0. Okay, 0 XOR with is 0. In this way, we can write the binary numbers. Okay, so similarly, 0, 1, 0, and again 1, uh, sorry, uh, then 1 XOR with 0 is 1, 1 XOR with 0 is 1, 1 XOR with 0 is 1. So again 1 with 0 is 1, 1 XOR with 0 is 1, 1 XOR with 1 is 0. Okay, so 0, 1, 1 XOR with 0 is 1. Okay, so then are you understood what I am doing here? B3 XOR with G2, so that is 1 B and B2 XOR with G1, again 0, and B1 XOR with G0, so again we are getting here. Again 1, 1 XOR with 0 is 1, 1 XOR with 1 is 0, 0 XOR with 1 is 1. So again 1, 1 XOR with 1 is 0, 0 XOR with 0 is 0, with 0 is 0. 1 with 1 is 0, 0, 0, 0 XOR with 1 is 1. Okay, 1, 1 XOR with 1 is 0, 0 XOR 1 XOR with 0 is 1. Okay, 1, 0. Okay, so 0 XOR with 1 is 1, 1 XOR with 1 is 0. Understood how I am getting the binary values here? Binary to grade code to binary.